Limitation of Octet Rule. I will teach you the complete concept of limitation of Octet Rule. First of all, we will learn about Octet Rule. We know that noble gases like neon, argon, krypton, etc. are stable gases. It is because they have 8 electrons in their outermost shell. From this universal fact, we conclude that any atom which has 8 electrons, it will be stable. Let me repeat it. Any atom which has 8 electrons, it will be stable. For example, consider sodium and chlorine. We know that sodium has 1 electron in its outermost shell and 8 electrons in the second shell, while chlorine has 7 electrons in its outermost shell. Now sodium will lose this 1 electron and chlorine will gain this 1 electron. As a result, ionic bond is formed and we get sodium chloride electrons. So sodium is stable. While in outermost shell of chlorine, there are also 8 electrons. So chlorine is also stable. Therefore, we define octet rule as the tendency of an atom to prefer to have 8 electrons in the outermost shell is called octet rule. Let me repeat it. The tendency of an atom to prefer to have 8 electrons in the outermost shell is called octet rule. Thus remember that any atom is stable if it has 8 electrons in its outermost shell. Now we will learn the limitation of octet rule. Well, in simple words, limitation of octet rule means it fails to explain the stability of certain elements like sulfur, phosphorus, etc. For example, the first limitation of octet rule is hypovalent species. By hypovalent species, I mean electron deficient species which have less than 8 electrons in valence shell. For instance, consider this boron trifluoride. In this molecule, boron is bonded to 3 chlorine atoms. There is no lone pair of electrons present on boron. We say that the central atom is boron, which has only 6 electrons. Its octet rule is incomplete, but it is stable. Or we say that boron is electron deficient species, but it is still stable. Thus, it is the limitation of consider this beryllium chloride. In this molecule, beryllium is bonded to 2 chlorine atoms. There is no lone pair of electrons present on beryllium. We say that the central atom is beryllium, which has only 4 electrons. Its octet rule is incomplete, but it is stable. Or we say that beryllium is electron deficient species, but it is still stable. Thus, it is the limitation of octet rule which cannot explain the stability of beryllium. Now, the second limitation of octet rule is hypervalent species. By hypervalent species, I mean expanded octet species which has more than 8 electrons in valence shell. For instance, consider this PCl₅ molecule. We can see that phosphorus is bonded to 5 atoms of chlorine. There is no lone pair of electrons present on phosphorus. We say that the central atom is phosphorus, which has 10 electrons. It has more than 8 electrons and it doesn't follow octet rule, but still this hypervalent species is stable. Thus, it is the limitation of octet rule which cannot explain the stability of PCl₅. Secondly, of electrons present on sulfur. We say that the central atom is sulfur, which has 12 electrons. It has more than 8 electrons and it doesn't follow octet rule, but still this hypervalent species is stable. Thus, it is the limitation of octet rule which cannot explain the stability of sulfur hexafluoride. Now the third limitation of octet rule is noble gas compounds. For instance, consider these compounds of xenon fluoride. We know that in xenon difluoride, xenon has 10 electrons, which is an example of hypervalent species or expanded octet. In xenon tetrafluoride, xenon has 12 electrons. It is also an example of hypervalent species or expanded octet. In xenon hexafluoride, xenon has 14 electrons, which is an example of expanded octet or hypervalent species. Thus, these compounds of noble gases demonstrate that the octet rule is not absolute because it cannot explain the stability of these compounds. Now, the last limitation of octet rule is odd electron species. By odd electron species, I mean molecules which have an odd number of electrons, and octet rule cannot explain their stability. For example, consider these molecules. In nitric oxide, there are total 11 electrons. Out of these 11 electrons, oxygen. These 11 electrons of nitric oxide means that one atom cannot complete its octet. Hence, octet rule cannot explain the stability of nitric oxide. In nitrogen dioxide, there are total 17 electrons, 5 electrons from nitrogen and 12 electrons from 2 atoms of oxygen. These 17 electrons means that one atom cannot complete its octet. Hence, octet rule cannot explain the stability of nitrogen dioxide. Finally, in chlorine dioxide, there are total 19 electrons, 7 electrons from chlorine and 12 electrons from 2 atoms of oxygen. These 19 electrons of chlorine dioxide means that one atom cannot complete its octet. Therefore, octet rule has limitation to explain the stability of certain molecules. Hence, noted down this important concept of limitation of octet rule.